Hello, this is Chuck Ridgway, Automation Technology Manager here at Horner. Thank you for joining us for another Tuesday live stream. Now today we think we've got some pretty good content for you. Today's show is hands-on with Ethernet Global Data. It's a protocol that a lot of folks don't know about, but it's really a good protocol, and we're going to teach you all about it today. And joining me is Mr. Casey Gardner. How you doing today, Casey?
Going, Chuck?
It's going pretty well. Now, I know that you work with customers quite frequently to talk about, maybe what communications protocols they should use or what their network architecture should look like. I know a lot of control engineers are somewhat familiar, or maybe even very familiar, with protocols like Modbus TCP and Ethernet IP. Not as many familiar with Ethernet Global Data, which we're going to talk about today. Now, when you talk to those customers, what kind of scenarios would cause you to recommend EGD as the protocol they should consider?
Sure. A lot of times it's when customers are trying to use maybe an existing Ethernet network or even establish maybe a new industrial Ethernet network and are looking for kind of recommendations on protocols to use. And controller-to-controller communications, EGD. A really simple protocol to set up and is very fast and efficient at doing so as well.
You betcha. So today we're going to tell customers all about it. Now, Casey will be manning the chat, so if you have any questions, you're watching live, go ahead and chat those in, and Casey will either answer them or save them for the end. If you're watching on replay, like a lot of you do, go ahead and type your questions in, but instead of the chat, you're going to type the questions in to the comment section. We'll get those answered non-real time. Casey will be back with me after we finish with the material. Okay, let's go ahead and get started. Okay, hands-on with Ethernet Global Data Protocol. So here's what we're going to cover today. Of course, we're going to start with what is Ethernet Global Data. We're going to do a comparison between EGD and Modbus TCP, as well as Ethernet IP, a couple other protocols more folks are familiar with. We'll talk about when you should use it. We're going to cover configuration. It's pretty straightforward, but there is a fair amount of configuration required. We're going to talk about some different example applications, and then we're going to do demonstrations of both kind of the standard setup procedure in Cscape along with how we would set up a specific example application. Okay, let's roll. So what is Ethernet Global Data Protocol? Well, Ethernet Global Data is one of the native industrial Ethernet protocols that's available in every OCS that features an Ethernet port. And these days, that's just about every model. It's a protocol that was co-invented by GE, their automation division and their drives division back in the late 90s. Now, some of you may say, wow, that's an old protocol. A lot of Ethernet protocols were developed during earlier days than that. And in the industrial world, Modbus TCP and Ethernet IP are about the same age. So a lot of protocols developed in the late 90s when industrial Ethernet became a thing. It utilizes UDP for messaging. Now, we're going to cover in a lot more detail what UDP is, but basically it's a type of messaging that still uses Internet Protocol, or IP, but it doesn't have as much overhead, it doesn't have guaranteed delivery, so it's more efficient and it's faster. But we'll cover that in a little more detail in a minute. But the bottom line is, it's a great protocol for distributed control applications where you have more than one controller, and anytime you need to move large chunks of data around effectively. So that's kind of what Ethernet Global Data Protocol is all about. Now let's contrast that or compare that with Modbus TCP and Ethernet IP, other protocols, again, more familiar to the industrial control engineer. Let's start with Modbus TCP. Modbus TCP, as most of you know, is kind of the de facto standard for interoperability between multiple manufacturers' gear. So if you have an application and you have gear from multiple manufacturers that needs to communicate with each other, Modbus TCP is definitely the most common protocol that's used for that purpose. Modbus TCP is a client-server protocol, so it's a pull and respond type protocol. Now it utilizes TCP/IP. We'll talk about it a little more in a minute. And again, interoperability is really what its strength is. Now, let's compare that with Ethernet IP. That is a protocol that's controlled by the ODVA, which is the same organization that originally created DeviceNet. And Ethernet IP includes both TCP and UDP message types. Okay, so it's almost like two protocols in one. For I/O type data, Ethernet IP uses UDP, just like EGD does. Okay, Ethernet Global Data does. For exchanging Logix data tags from Logix CPUs, it utilizes TCP IP. Okay, now where is it great when you're talking about an OCS controller? Well, if you need an OCS controller to interoperate with Rockwell PLCs, Ethernet IP is a great choice. Whether you're talking I/O data or whether you're talking exchanging Logix tags, both cases, those are great choices. Now let's go into a little more detail on this slide about TCP versus UDP. And remember, Ethernet Global Data utilizes UDP. Elements of Ethernet IP also utilize UDP, the I/O portion of it. For TCP, that's what you'll find with Modbus TCP and some elements of Ethernet IP. With TCP, it's a connection-based protocol. So there's a series of messages that get exchanged between nodes just to establish a connection. There's also error recovery built in. Both of those things result in higher bandwidth requirements because there's more bytes flying back and forth over the wire. It's also somewhat slower to utilize TCP for your transmission. UDP, on the other hand, which stands for User Datagram Protocol, is a connectionless protocol. So there's not a bunch of messages that have to be exchanged before communications can commence. Error recovery is not built in. That's the responsibility of the receiving device. So if you're a receiving device and you're expecting to get data from another node over UDP, you have to handle properly what happens when that data just isn't there anymore. Now, because of the fact it's a connectionless protocol and error recovery is not built in, it has lower bandwidth requirements and also it's faster. Okay, so those are the differences there. You can tell from looking at this comparison that Ethernet Global Data is going to offer good performance with lower bandwidth usage, but there's going to be some error recovery that you're going to have to handle that is not handled by the protocol. Okay, now when would we use Ethernet Global Data? This gets back kind of the conversation that Casey and I had before the show today. One result where you would use EGD is when a pull/response protocol like Modbus TCP is impractical or too slow. Let's say you've got an example of a host device that needs to communicate with 30 other server type devices. Well, with Modbus TCP, that client is going to be polling one after the other the 30 other devices in order to exchange data. That's going to take quite a bit of time, maybe several seconds. So in some scenarios, especially if you're talking to controller communications, that's just too slow. You know, a few seconds is fine for SCADA maybe, but it's not going to work for a application with multiple controllers where you need to do distributed control, for instance. And let's talk about distributed control. When you're using multiple controllers in a distributed control environment and they need to share data, sometimes large chunks of data, that's the other scenario where EGD works great. Okay, let's talk about how it works. EGD is based around the fact that controllers are going to produce and consume what are called exchanges. And you can think of those like an envelope. An exchange needs to be configured where data is to be sent, you know, what's its destination, where the data is going to be sent from, okay, what's the source of the data, how often is the data going to be sent. Now, the way EGD works and the way a lot of UDP protocols work is that instead of having error recovery built into every single message, they just send the data frequently so that if a message is missed, it's no big deal. There's another one coming right down the pike. But you do have to set up how often you want to send the data and how often you're expecting to receive the data. Another thing that has to be configured, of course, is what data is going to be inside the envelope. So the exchange is like an envelope, and what's called a range is what's inside the envelope. Now, an exchange can be sent to one recipient, that's called unicast, or a single exchange can be sent to multiple recipients. That's called multicast. Configuration is required both on the produce side and the consume side. So that's the how it works portion of EGD. All right, now let's talk about configuration. And that's really where our hands-on period is going to happen this week. And that is, how does configuration work? And we're going to show you how to do it. So first thing we have to do is we typically are going to configure the produce side. Who is sending the data? And first we're going to start with configuring the exchange for that produced data. We're going to assign an exchange number. So every exchange has to have a number, and it's going to be in the range of 1 to about 16,000. And a typical OCS could send as many as, I believe, maybe a couple hundred exchanges. Now, most applications just have a few. So after we set the exchange number, we need to assign who we're sending it to. Are we sending it to a single IP address, another single device, or are we sending it to a group of devices? All right, if we're sending it to a single device, we're going to assign an IP address. If we're sending it to a group of devices, we're going to assign what's called a group ID, and that's a number between 1 and 32. And then we have to assign how often we're going to produce the data or send the data in milliseconds. Typical times might be 100 milliseconds or 250 milliseconds or 10 milliseconds. So after we've configured the exchange, which is the envelope, now we have to put data inside the envelope. So when we do that in Cscape, we've got a pull down list of what can go inside the envelope. Data is the first thing we need to put in it. So we select data, and then we set the starting address and the number of registers that we want to put inside the envelope. Now today I'm going to be teaching EGD using register-based logic. It works perfectly fine in variable-based logic, but it's just easier to explain in register-based logic. So that's the only reason I'm using that today. It's just for ease of explaining. Okay, so once we've put a bank of registers inside, we aren't limited to just one register. Maybe we're going to put in register 1 through register 64. And then after that, maybe we need another bank of registers or maybe a bank of bits. We can put multiple blocks of data in consecutively inside the envelope. That's no problem. As long as we stay below 1,400 bytes of data inside the envelope or inside the exchange, we're good. Now, once we've put all the data in there that we're going to send out over the network, we should assign a local produced status register. So this is a status register that's going to tell us that, okay, the data is going out okay, but that data is not going to be sent out over the wire. Okay, every device that's consuming the data is going to have their own status information that they'll handle on their own, okay, on the receiving side. Okay, so that's the configuration on the production side. And with EGD, you have to configure the data that's produced through configuration of the exchange and the range. You also have to do the same thing on the receiving side. So now we have to configure the consumed side of the exchange. When we set the exchange number here, it needs to match the exchange number that was assigned at production time. Now, we also on the consume side always have to set the IP address of the producer. Regardless of whether this information is coming only to us as a unicast, or whether it's going to a group that we're included in as a group, we always have to assign the IP address of the producer. If it is a multicast type message to a group, we also have to set the group ID to match that on the produce side. And then we're going to assign a message timeout. This is not the same number of milliseconds as the production time that was assigned on the produce side. This is a larger number. So if we were sending the data maybe every 10 milliseconds, we might be setting a timeout for 20 or 30 milliseconds, that sort of thing. Once we've configured the exchange that we're consuming, we have to configure what we're going to do with the data that comes in that's inside the envelope. So what we're going to do is we're going to take the data that's in there and we're going to move it into our local register space of the consuming OCS. And it doesn't have to be the same register numbers that they were put in at on the other side. Okay, so if the producing OCS put register 1 through 100 in the envelope, that data could be pulled out by the consuming OCS and stuck into register 1001 through 1100 if you want. So it doesn't have to go in the same locations. It's a completely different OCS controller. Next, you're going to assign a status register so that you can tell if communications is working properly If it's not, you can take corrective action. That's the whole error recovery, the responsibility of the receiver that we talked about earlier. And then as an option, if you want, you can also map in the timestamp of when that message was transmitted. You can map that data into a local variable so you can read that. There's not a lot of applications where the timestamp is critical. If it is, you can go ahead and map it into a local variable. Okay, so that's the configuration, what configuration looks like on EGD. Here are the details on what you get in your status register, both on the produce side and the consume side. On the produce side, really the only information is okay, or there's no link, or Ethernet is down. Okay, that's really what you're going to get there on the produce side. On the consume side, there's a little more information there. You have okay, like you're hoping to see continuously, but you also have, of course, no link or Ethernet is down. But in addition to that, if the timeout you've set is exceeded, but the data still comes in, then it's known as tardy. So that would be status 7. If the data comes in and the data doesn't come in at all and your timeout expires, then it's overdue. So as long as your status is a 1 or a 7, you're good. If it's a 6, then you've got an issue, you've lost your link, and you need to take corrective action. Or a 2, of course, same thing. Let's go ahead and dive into configuration. I'm going to go ahead and fire up Cscape. Okay, so we're going to go ahead and do a configuration from scratch. So I'm going to go ahead, go with a new file. Okay, and again, today I'm going to teach on register-based. It works perfectly fine with variable-based. Okay, and I'm going to start by going into the hardware configuration and the LAN 1 config. It works on both LAN 1 and LAN 2 if you have a XL7 or an EXL10 or an XL Plus, for instance. Okay, so if you're going to use Ethernet Global Data Protocol, you need to make sure that Ethernet is set up the way you want in terms of IP address, net mask, etc. So that's a requirement. You need to set that up to meet your requirements. And then to set up EGD or Ethernet Global Data, you just select it here on the list of resident protocols, and you make sure it's highlighted and you hit Configure Selected Protocol. And we start by configuring any exchanges that this node is going to be producing. So we start there. Let's add an exchange. Remember, think of it as an envelope. The exchange has to have a number between 1 and 16,000. I'm going to start with 1. Makes sense, right? Am I sending it to strictly an IP address to another node, or am I sending it to a group? Let's say I'm sending it to a group. I have to assign a group ID between 1 and 32. Let's start with 1. How often do I want to produce the data? Let's say this is pretty important information and I want to send it out every 10 milliseconds. Okay? So I've now configured the envelope that my data is going to go in. I've configured the exchange, but I need to put data inside of it. All right, so what do? Well, I make sure the exchange is highlighted and I hit Add Range. Now let's start putting data inside of our envelope. Our choices are data or status. We're going to get to status later. What address do we want to start with? Again, I'm starting with register-based logic today. Let's say we want to put in register 1, or we want to start at register 1, and we want 100 registers. Okay, so we're putting 100 words in. R1 through R100 is going in the envelope. Next, maybe we want to put some bit type data. All right, let's say we're going to start at %M193, and we're going to put in 64 bits. Okay, we'll put that in the envelope. This needs to be in a word boundary. That's why I've selected that number. M193, just like, M1, M33, etc., are on a word boundary. Okay, so let's say that's all the data I want to put in there. I could put more in if I wanted. I'll just go ahead now and I'll add range here, and this time I'll add status, and I'll go ahead and say register 200 is going to be my status register for my produced data. So this is where I need to make sure that I've got a value of okay in there. If I don't, then, I know that I've got an issue. So that's the configuration on the produced side. All right, it's exchange number 1, produced to group 1. Here's the data I put inside it. Now, to configure the other end of this same exchange, I need to go to another Cscape project because this data is going to be received or consumed by an OCS, a totally different OCS. So I'm going to open another new file, Okay, still sticking with register-based logic for today. Going back into the hardware configuration, and this consuming OCS still has a requirement of having a full Ethernet configuration. I'm still going to select EGD, make sure it's highlighted, hit Configure Selected Protocol. Now I'm going to go ahead and start on the consumed side, okay? Because I'm going to configure the consumption of the exchange I just configured with the other Seascape project. I hit Add Exchange. Now I can't just pick any old exchange number, it needs to match what I configured on the production side. So I hit 1. Now regardless of whether this is coming in as part of a group or to a group, or whether it's coming in from a single IP address, I need to configure the IP address of the producer. So let's say that this is the IP address. Now, if this is going to vary, I could assign a variable here. It doesn't have to be hard-coded, but I'm going to go ahead and hard-code it here. This is coming to a group, so that has to be configured properly. And remember, it was group 1 that we assigned. And now I have to set a timeout. It's sent every 10 milliseconds. Let's say I want to consume it every 25 milliseconds. It's still going to come in every 10 milliseconds, but it's not going to be late until it takes longer than 25 milliseconds to arrive. Okay? So my envelope, my consumed exchange is done. Now let's add a range of data. All right, now if you remember correctly, there were 100 words of register data. Let's go ahead and map those in. Again, I can map them to a completely independent location in memory. I'm going to put them in R1001 here locally. Has nothing to do with what registers they were pulled out of on the other end on the other OCS. Oh, please enter an integer. Constant not allowed. Okay, knucklehead. Let's type this in properly. R100, length of register 100. All right, I reversed those fields there. And let's go ahead and add those bit types now. Let's say we want to put those in right at the very beginning. Okay, and let's go ahead and add status, because it's important that we have status on the receive side, especially because that's what's going to tell us that, hey, the data we're expecting did not arrive. Okay, let's take a look at this summary here after we're done configuring. What you'll see is the starting and ending point for all the data in the envelope. Here's where we have our 100 words of data in register form. Here's where we have our 64 bits after that. And here's where we have status. Now, at the beginning here, there's a byte offset that's put on the list. So this tells us how many bytes into the data before we actually get to this particular part of the information. So this register data starts at the first byte with no offset. This bit data starts at the 200th byte, or 201st byte, I should say, with a 200 byte offset. So that's configuration on both sides for a single exchange that was produced by one OCS and consumed by another. Now, every OCS has the capability not only of being a consumer for data that's produced elsewhere, but that same OCS can also produce its own data that's consumed elsewhere. So we just showed one side of it in this particular case. Let's head back to our material and continue on. Okay, we're going to talk next about an example application. Okay, so here's an example of an application where you would want to use EGD because it's a great alternative to some of the other protocols. Let's talk about an application where we have mobile assembly carts. Okay, so we've got an assembly plant here. Maybe we're assembling some sort of relatively small product, and we're going to assemble it on a cart. And we have, let's say, 16 carts, and there are multiple assembly stations, and a cart will move from station to station as a different part is added to the assembly. So in this example, each cart is battery operated. So we might be talking about a wireless Ethernet type implementation here. And each cart is controlled locally by an XL4. So going around this track in an assembly area is a small cart with an XL4 controlling it. Okay. Elsewhere in the assembly area, there's an XL7 that's coordinating the movements of the carts on the assembly line. So each XL4 is responsible for controlling the cart, and the XL7 is responsible for coordinating everybody's movement. Now, what if we used Modbus TCP here? Well, the XL7 that's communicating with all the XL4s, with all the carts, it would have to talk to them in a round-robin fashion. It would have to poll one at a time to get information, and then when it was ready to write information, it would need to interrupt its poll and go write information. That might take several seconds to actually happen. So why would we use EGD? Well, because we can overcome that limitation, because this is not a scenario where our messages are on a poll response type basis, that you'll see with a lot of client server protocols. Effectively, by using EGD, it would allow the XL7 to send multicast data to the cart XL4s with a single message. In other words, we could send out one big blast of data from the XL7, and that big blast of data could be received by all the carts, more or less at the same time. And those carts could take the data they need out of that big blast of data and use it for their own local purposes. In other words, they would receive in the commands they need to receive in from the XL7 by pulling the data they need out of that big blast of data. Now, for status coming back the other direction, each cart on a periodic basis could send out a single message. They could produce a single message that would be consumed by the XL7, providing status information. The cart could be saying what station it's located at, or whether it's busy or whether it's complete, or whatever the case may be, whatever that status happens to be. And then depending on the available bandwidth, certainly update rates less than 100 milliseconds are completely practical. And keep in mind, every XL4 is controlling the cart locally. It's just getting coordinating information from the XL7. It's great that that comes in, say, every 100 milliseconds or every couple hundred milliseconds. It would not be so great if that was coming in every 5 or 10 seconds, which could happen with a poll respond type protocol. Okay, so let's map out the data and see what that's going to look like. Let's start with our coordinator XL7, the command data it's going to send out to all the carts. So I've listed there kind of an example of a big blast of data that it could be sending out to the network, which is going to be consumed by the carts. And then every cart is going to receive that blast of data, say every 100 milliseconds, and then it's only going to use the data it cares about. Okay, so it's going to receive in all the data, but through a little bit of logic, it's just going to go ahead and use what it needs. And that's going to be true in every cart. And then in the end, every cart is going to have kind of some common command data that it's going to store and say register 1. That could be things like what's the line speed supposed to be set. It's data that everybody cares about, all the carts care about. And then it's also going to have another bank of registers, say starting at R9, that might be individual commands that are specifically targeted for that particular cart. Okay, so that's an example of how the data might flow from the coordinator XL7 to each individual cart, XL4. Now let's look at data coming the other direction. Every cart is going to be sending status to the network, a single exchange, and then the coordinator XL7 is going to be receiving that status information through 16 different exchanges, because every cart is going to be not broadcasting, but unicasting that data to the network, and that status information for that cart will be received in and mapped in on the coordinator side. So that's really what we're looking at. If we take a look at what the configuration might look like, and we'll go through this, with a live in Cscape here in a minute, but effectively, let's start at the coordinator side for the data going from the coordinator to the XL4s. Basically, you have a single multicast type exchange where you're sending out a single bank of data, okay, that's going to be ultimately received by the carts. And then that same coordinator on the consumed side will have 16 consumed exchanges that have to be configured, one per cart. So that's what it looks like configuration-wise on the coordinator. If we take a look at what the configuration is going to look like on the cart side of things, each cart is going to be consuming in just one bank of data. And then in logic, and I'll show you how to do this, it'll be basically pulling out only the data it cares about from that big bank of data from the coordinator. And then each cart will also be producing one message, all right, which has status information that ultimately will be sent back to the coordinator. Okay, so that's what things look like from a data breakdown standpoint. Much more efficient than a pull respond with a slow response type scenario. More configuration, but pretty straightforward. All right, let's go ahead and go through this in Cscape now and see how we might implement this, or see what it looks like once it's implemented. Okay, I'll go ahead and close out these programs that we just configured from scratch when we showed you how it was configured. All right, so let's start with the, oh shoot, I closed the XL7 program. No big deal. Let's go ahead and close the proper program. Okay. And let's go ahead and open up our coordinator program, which is our XL7. Got it. All right. So let's start by taking a look at the configuration of our coordinator. All right. So again, we're going into our Ethernet configuration, and we're going to make sure EGD is highlighted, and we're going to examine what that looks like. Okay, so on the production side of things, we're sending out, for exchange number 1, we're broadcasting this to a group. Okay, it's going to end up being every cart is going to be receiving this data. Okay, and we're sending it out every 50 milliseconds, pretty frequently. Okay, probably more frequent than absolutely necessary. But that is the frequency of the data that's being produced. And here is the data we're sending. And effectively, we have 72 registers. And if you remember how that broke down, we have 8 registers that all of the carts care about. And then there are an additional 4 registers per cart that they're going to be caring about. That's going to be specific instructions from the coordinator to the specific cart. Okay. After that, we simply have a status register that, again, is going to tell us that either the network is down or that the data seems to be going out okay. Okay, so that's what things look like on the production side for the coordinator. Now let's take a look at what it's going to look like on the consumed side at the coordinator level. Okay, so this is the data that's coming in from the carts, from the XL4s. So what we've got here is we have 16 exchanges that have been configured, 1 per cart. Okay. Here's the unique exchange numbers from the ID of the cart that's sending the information. Does not have a group ID affiliated with it. And then we've set a timeout for receiving the data at about 100 milliseconds. Okay. And the data coming in is just the forwards from each cart, that's status information, along with, I'm sorry, when I say status information, I mean status from the carts, as opposed to the communication status, which is coming in here. All right, so that's what the EGD configuration looks like on the coordinator side. Now let's go ahead and take a look at the cart side. Now, one of the goals should certainly be to have a single cart program, a single cart logic program that is used by all the carts. So we don't have, if we can help it, so we don't have 16 different programs to maintain, 1 per cart that's unique. So the goal here would be to have effective communications and to have a common program that can be used by each cart. So in the end, we have 2 programs to maintain, the program in the coordinator and the program in the carts. So let's start at the EGD configuration. So we're going to go to LAN 1 config, make sure things are configured the way we want them. Now, one thing that I've done here is I made sure that my IP address, at least, is sourced from a register. Now, this is not an EGD specific requirement. This is something I've done to help allow one program to be used by every cart from 1 to 16. By having a configurable IP address, that helps make that happen. Okay, now let's take a look at the details of the EGD from the cart standpoint. Let's start with the data being consumed from the coordinator. we're just bringing that all in, okay? The first 8 words we're bringing in to a specific variable or set bank of variables starting at R1. Because if you remember correctly, those are the 8 words of command data from the coordinator that is important to every cart. So the first 8 words are important to every cart, so we're going to map that away to R1 through R8. The next 64 words, 4 words per cart, the next 64 words has all the data going to all the carts, and we're going to receive it all in. But in logic, we're going to pull out the 4 words of data that are meant for this cart. Okay, so we're going to do that in logic. We're not going to do that in the EGD configuration. And then in terms of the data that's being produced by each cart, pretty simple. It's, again, being produced to the master. It's not global. And there's simply 4 words of data that each cart is going to send back to the master with just, status information. I'm full, I'm busy, whatever the case may be. Okay, so that's what that looks like. Now let's take a look at the logic that we used to allow us to effectively have a single program that'll run in any of these carts. And I missed one thing that's important, and that is, let's go back into the configuration. All right, LAN 1. And let's go back to EGD. And let's take a look at the data that each cart is producing. You'll notice that I didn't put an exchange number here for the produced data for each cart. I put a variable instead. That allows the exchange number sent by each cart to be a variable that varies depend on what their ID is. So if I'm cart number 1, I need to produce my data under exchange number 2. If I'm cart number 12, I need to produce my data as exchange number 13. So the exchange number can't be configured as a constant, because if it is, then I will no longer have one program I can use among all carts. It would have to be unique for each cart. I don't want that. So I've assigned a register for the exchange number, because that's something that will vary depending on which cart number I am, okay, when this is running. Okay, so that's an important point here. All right, so everything else logic-wise, I'll show you here, is really all about just a little bit of logic in here to ensure that regardless of what cart number I am when I'm running this, whether I'm cart number 1, cart number 5, cart number 16, that the appropriate IP address is configured, the appropriate exchange numbers are configured, etc. And that I pull out the specific 4 words of data that were intended for me as cart 1 or me as cart 5, etc. So let's start with the IP address configuration. In this case, it's a fixed IP configuration, but the last octet, the last number in the IP address, varies depending on the cart number. Okay, so this is where we set the variability for that last octet. So the IP address of each cart is going to be somewhere between 201 and 216, depending on the cart number. So we basically add 200 to the cart number to get that last number of the IP address. Okay, the first 3 octets are fixed. From the standpoint of the EGD exchange number for the data we're producing back to the coordinator, that's just adding 1 to our cart number. So if I'm cart number 1, I send my data back as in exchange number 2. If I'm cart number 7, I send my data back in exchange number 8. Okay, so that handles the variability there. And then down here, this is where we're going to pull out the 4 words of data coming from the master, from the coordinator, that I need to pay attention to as cart 1 or cart 5 or cart 7. So I calculate an offset. Remember, this data all came in starting at register 501. I calculate an offset so that I can perform an indirect move and move the right 4 words into the local register that requires or that receives in, if you will, for use in the logic program, the data coming from the coordinator. Okay, so this is an indirect move. Okay, so these are the kind of things that we can do in our program to ensure that in this scenario where we have multiple controllers and these controllers, a lot of them are running the same program, at least they will if we can configure it that way. This is some of the programming we did to make that happen. Hopefully that was clear to everybody. Okay, to kind of hammer home the point, I've got a screen that I created here to kind of mock up what you might find on, say, a network configuration or network setup screen on one of these XL4s that's running a cart, to show how that we could just change the cart number and modify the IP address as well as the produced exchange number for the data that we're sending back to the coordinator. So with cart number 1, my produced exchange number is 2, my IP address ends in 201. If I'm cart number 2, my exchange number increments, that's the variable that I'm using inside my EGD configuration for that produced exchange, and then also my IP address changes. All right, if I'm cart number 16, you can see my exchange number and my IP address changing as well. Okay, so again, these are steps we can take through programming and through EGD configuration, including variables, so that we can have a single program that's being run by multiple controllers, all doing the same thing and talking on the same network using EGD. Let's head back to bring in my colleague, Mr. Casey Gardner. There we go. I've got Casey now. Sorry about that, Casey. Okay.
No worries.
So from the standpoint of questions and answers, did we get any questions today?
Yeah, we got a couple.
Okay.
I was just working on one. One that came in was, where'd it go? One question we had was, can a LAN configuration have both a Modbus and EGD configuration at the same time? And the answer for that is absolutely. Luckily, Ethernet is flexible to have multiple protocols at the same time. So you do Modbus and EGD, but you can do a number of others on top.
Absolutely, including things like WebMI and sending and receiving or sending emails, those sorts of things. Great.
FTP, all the above.
You bet.
Good question there. And then we also had another one that I was looking into. He was asking for a link for the specification of the EGD protocol. I hadn't seen a specific link to the protocol itself, but I can link in a list to our documentation for some Ethernet supplement documentation that kind of goes into the protocol and configuration into a little more detail. So I'll go ahead and post that in that section as well.
Absolutely. So the Ethernet Global Data Protocol is covered from a documentation standpoint in our Ethernet supplement, which Casey will post, as he just mentioned, and it's also available on the product page, I believe, for each of the products, as kind of listed right along there with the user's manual. Okay. Terrific. Thank you, Casey. I appreciate that. I want to remind everyone that next week, oh, there we go, that every week on Tuesdays at 2 o'clock, we have another YouTube session on YouTube and on Big Marker where we cover another technical topic. In addition to that, I want to remind you that next week, we're going to be covering using a custom font with a Horner OCS controller. There's a variety of situations where you might need to use a custom font. Maybe you need some really large text, or you need some really squeezed text to be able to fit a lot of characters on the screen. Whatever the case may be, we're going to cover that next week. Also, don't forget, if you haven't already, go ahead and subscribe. That way, especially if you ring the bell, you'll get a notification anytime we post a new video or anytime we go live. And our subscriber totals are rising up nicely, and we really appreciate that. Now, until next week, everybody stay safe out there.